Okay, so welcome back to how to solve a 4x4. This is the part 2. By now you should have already watched the part 1, so you should have known how to solve the centers. Now I'll be going over edge pairing and how to do the rest. Okay, so to pair edges, first you need to find two edges of the same color. Like right here I have the green and orange edge. I'm going to search for another green and orange edge, and that's right here. So I'm going to get this edge and this edge in the same layer. So I see this layer, right? So I'll just turn the cube a few times to get it in the same layer. Most of the time they'll be adjacent like this, and this will be the other color on this side, and this will be the color on this side. This is a good situation. And if there's this situation, then you want an unpaired piece over here, and then this is how you do it. You're gonna slice over one of the edges to the other, which will match them up. Move that up, replace it with that unsolved bit we were talking about. Bring it back, and undo the slice. So that's one way to do it, to pair up an edge. Second way, you might have them straight across from each other. This way I have actually both straight across. But if you have them straight across and not diagonal or adjacent, then you got to do this tiny algorithm. Keeping that on the top, you just do R prime, U, F prime. It's not a big algorithm. Okay? I'm sure you might be able to remember that easily. Now, that is, then you will get it adjacent. And now you can again keep an unsolved bit in front. Slice it, match it up like that. Bring it up, replace it with one of these, reverse that move, and reverse the slice. Like so. Now on to another one. Example, I can use this orange and yellow and this orange and yellow. So they're in place. So this is unsolved. So I can slice this across, match it up, move it up, replace it with a broken edge, bring it back down, and slice back. So this way you can go ahead and pair up almost all the edges. But when you come down to the last two edges, there'll be a few cases. Now I'll be doing the edge pairing in front of you, so you'll be able to get a better idea of how it's done. So here's an edge, match them up, move it up, replace it with the broken, bring it back, and unslice. Here I have the blue and blue. The straight across, so I just use that simple R prime, U, F prime to get it correctly. Then bring this over, slice it across, replace it, bring it back. Done. So now the next, I will look for a green and white. As you can see, green and white is right here. So I'm gonna go ahead and look for another green and white. Oh, I see a green and white here, so it's right there on the same layer. So I can move it like this, so that they're on the same layer like this. But they're straight across, so use the R prime, F prime. They're like this now. And, oh yeah, all the algorithm and the sheet of algorithms will be at the end of this video. So, that's done. Now let's look for another. I have these two straight across, so use the tiny algorithm, take an unsolved piece. Now I will slice across, replace it, bring it back. Now these two are set up too, so just need to do the tiny algorithm. Slice across, replace, and bring it back. Now, there are only a few things for the last case, for the last two edges. Let me just get to that point and I'll explain. So again, I think there's just three more to pair. So if I pair up this, it'll probably be done. So slice across, lace and back. Oh, so in this case, I solved both mine. So I'll just set it up for you. Just wait. Okay, so there's two ways you can have it. You can have them both straight across like this, or you can have them adjacent to each other like this. Now you don't want them adjacent to each other. You want them straight across, and if it's adjacent, then just use that same algorithm we were using. Now they'll be straight across, or the algorithm is just the R prime U F prime. Now this is the algorithm you need to remember. Slice along with this layer, or if you want, slice both the layers. Now do this algorithm. That's like a DW or DD, which is both the bottom layers. And do R, F prime, U, R prime, F, and undo that. First move. Now you should have the last two edges solved. Now, from here, you solve it like how you would solve a regular 3x3. So, I am getting it to a point where I can show you two other cases possible. So, I solve it like a 3x3. Oh yeah, and you will need to know how to solve a 3x3 for this. If you do not know how to solve a 3x3, then just go over to my other video. And last one. Now I will say I am using a different method than what I taught you, but I am going to get the same result. So the next bit, I'm going to talk about it while I'm solving this. So the next bit is just a couple of speed bumps. You may not always get them, but the next bit is called parity. So, example, there'll be cases that were impossible on a 3x3. So this is a regular CFOP OLL. Done. Now for PLL, I'm going to check if everything is normal, because it may not be. And no, everything is not normal. This can be a U-perm if you know what CFOP is. So it's just an algorithm. For those of you who don't know, it's just an algorithm. But you'll see that only two corners are switched. This is one kind of impossible case. This is called corner parity. There's an algorithm for that I will give at the end of the video, and a sheet that I will show you. You can take a screenshot of that at the end. So right now, this case, you can solve it using an algorithm. MR2, U2, MR2, UW2 or UU2, MR2, UU2. I call it UU2 and not UW2. Now, this is solvable. You can solve it. You can go about solving it again however you regularly would. In this case, I use CFOP. So, for you CFOP users, you can use the D-perm. And now I have an E-perm. It's not a very good case. You know, the E-perm is not a good case. But it's solvable. And you will have solved your 4x4. Now, there is one last case that I will get into in just a moment. Just a second. Now, this case is called edge parity. Now, the reason why is because just one edge or two edges in this case are flipped. The reason why this is impossible on a 3x3 is because in this isn't actually one edge, it's two edges. And there is an algorithm on a 3x3 to swap or flip two edges. So that's why it's possible on a 4x4. And this is the big long algorithm, and I will tell you right now. MR prime. Oh yeah, and MR is just this up. ML is just this down. So MR prime, U2, ML, F2, ML prime, F2, MR2, U2, MR, U2, MR prime, U2, F2, R2, F2. Okay, so that's how you solve the 4x4. And last but not least, I will be showing you my algorithm sheet for the 4x4. So, right now I'll be telling you what the algorithm sheet consists of. So, the algorithm sheet consists of different things. Only it doesn't have the 3x3 algorithms. It only has the 4x4 specially algorithms. Okay, I'll just put this cube here. Okay, so it does not have all the algorithms even for the 3x3, but you should already know how to solve a 3x3 by now, so there it is. I did not write the R prime U F prime because I'm sure you could get that yourself. You know what? In fact, with just a simple marker, I'll just write R prime U F prime. Now you can go ahead and screenshot it if you would like. Oh, sorry, it's just lifting off. Okay, now if you'd like, you can screenshot this. I'll give you a few seconds. Okay, so that's it. That's it for the tutorial on how to solve a 4x4. If you are still confused, I will post another video. Just another video explaining in detail what parity is. Okay, don't forget to like and subscribe. And check out my brother's channel, Brothers of Dhruv and Cubing. I'm Dhruv, and bye.